So while the slides are coming up, let me give you a quick 1-minute preview. I think since morning we have heard about what is Hadoop, what are big data, what are the use cases, why is it relevant, and now we'll go on to see, okay, now you have crossed all of those barriers. If you want to implement a Hadoop cluster, what do you need to do? That's what we'll be talking about in the next few slides. And the main theme, if you have to leave today with a 10-second takeaway, that 10-second takeaway would be bigger is not better. So yes, people would say scale it, you have to build bigger cluster, or you have to get more hard disks, or you have to put more CPUs. Don't get drawn into that controversy. That's what the main takeaway is. Just a quick 1-minute background about our company, Exar. It's headquartered in Fremont, California, publicly traded company, about $500 million market cap, and 1/3 of the business is in the data management or Hadoop acceleration solutions. So big data. I mean, the main point, as I was telling earlier, was with 42 Hadoop nodes, even this guy looks cool. Okay, why? Because everybody says bigger is better or more nodes means good. However, is it really that bigger is better? That's what we will today try to find out. So we have heard about petabytes of data, multiple hundreds of terabytes of data, and where does all of this data sit? It all sits in a data node. And if you want to crunch data that's essentially in hundreds of terabytes or petabytes of data, you will often hear from many OEMs that, hey, if you want more jobs done per cluster or per data node, then put more CPUs or put more storage into it. But in our view, no, take a given rack, try to optimize the ratio between the CPUs and the hard disk, or any memory, CPU, hard disk network. Try to optimize those resources, and you will get much better results. The second myth we often hear is that capital expenditure determines when you're trying to buy a Hadoop cluster, which is what is the upfront cost that you have to pay. But in reality, it's not really CapEx that determines the TCO or total cost of ownership, it's the OpEx. Why? Each hard disk consumes about 20 watts of power. You run tens of thousands of analytics on a given day. Therefore, there is more and more OpEx involved over a 3-year period. And at the end of the 3-year period, we believe if you take electricity and disk replacement costs, our analysis say that 75% of your TCO is OpEx and 25% is CapEx. The third myth we have heard many times, even some of the speakers were saying today that storage can scale easily. But the reality is no, storage cannot scale. Why? At some point, if you take a given 2U rack, there are only so many disks you can put in it. And also, most importantly, the amount of power you require and the amount of cooling that needs to go in, you cannot scale storage. So make sure that if somebody is saying you have got 150 petabytes of data, you nail yourself and ask, am I storing the 150 petabytes of data in the most efficient manner? The final thing is compute defines the node cost. The answer is no. You get in a typical data node, you get 2 CPUs. These CPUs are 6-core CPUs or 8-core CPUs, but they are supporting roughly 12 to 18 disks. And each disk is at least 2 terabytes, if not 4 terabytes. That means 2 CPUs are essentially supporting up to 24 to 40 terabytes of data. Therefore, make sure that you understand it's not CPU, it's the data intensity that you're dealing with here. And finally, I think there was at least one speaker who corroborated with this point earlier, network traffic, which is you have got this petabytes of data, and you're trying to move them from one cluster or from one portion on the globe to another portion where you have another cluster. Make sure that you take care of your network bandwidth, because 10 gig links are almost 3 to 4 times more expensive than your typical 1 gig links. Of course, that depends upon the distance. So make sure you optimize your network bandwidth as well. So in summary, if you are being an architect who is architecting a Hadoop cluster, the 3 things you have to optimize is, one is storage, which is make sure you don't store all of the data on an as-is basis. 2 is make sure that you're able to read maximum amount of data, the disk IOPS. You're able to go ahead and read maximum amount of data in any given, or write it in a given read-write cycle. And 3rd thing is make sure you minimize your network bandwidth. How do you do that? So to do that effectively, This gets a little bit technical, but if you're an architect or if you're a business user, the main thing you need to know is how do you optimize CPU, system memory, I/O bandwidth, and network bandwidth. If you try to optimize these 4 resources, what you can find is without compromising the analytics capability of a given cluster, you can reduce the total cost of the cluster by 30 to 40%. And that's what Exar offers. These are 2 technical slides. In interest of time, I'll try to showcase to you how have we implemented. Is this all slideware or have we implemented? So let's take a typical test structure. What we have done is we went to the top OEMs, including the likes of IBM, HP, Supermicro, etc. We worked with them to define a typical Hadoop cluster, and then we took a typical, the most used analytics is TerraSort in any Hadoop. So what we have worked with them is, we said, okay, give the most powerful cluster you have, try to sort a given amount of data, 1 terabytes, 2 terabytes, 8 terabytes of data, determine how much time would you require and what was the total cost of the cluster that was able to sort 8 terabytes of data. And then what we did was we put in the Exar solution, and then we benchmarked it again, and then we saw how did the 2 solutions compare against each other. So in the first OEM, it was a very typical data node cluster, 8 data nodes with 2 management nodes. They were dual 6-core CPUs. It had up to 48 gigabits of memory. And when we ran the analytics, what you'll find is, in order to sort 512 gigabytes of data, it took them 38 minutes and 16 seconds. So they were able to do 512 gigabytes of sorting in 38 minutes and 16 seconds for the given configuration. Then we put Exar solution, and from each of the data node, we were able to take 6 disks out. What does it mean for the audience in this room? It means that, let's say that a typical 2 terabyte SAS drive costs $400 to $500 per data node. So you're able to eliminate up to 10 to 12 disks. That means $6,000 worth of hardware from each data node. And when you ran the analytics again, what you'll find is we still were able to finish in 33 minutes. So we took 50% of the disks out, and yet we were able to complete the analytics in about 15 to 20% less. That was our first proof of concept. We worked with OEM. Then came the question, the OEM's technologists or the people who ran the tests okayed this. Then we went to the product managers from a CFO and a CFO perspective. There what we found out was, if you did not use an optimized or an accelerated solution, Hadoop clusters are sold by terabytes. A 300 terabyte Hadoop cluster typically costs about $160,000. Whereas if you use an optimized cluster with reduced storage and reduced CPU, we were able to reduce the $160,000 cost to about $97,000. That's about a 30 to 40% reduction without doing any code changes, without modifying any hardware. We just optimized the CPU, the memory, the network bandwidth, and I/O utilization. Those were the 4 things we had optimized. In case of the second OEM, they had a full 40U rack. In that 40U rack, they had 10 servers for doing analytics, and they had 10 expansion units for storing all of the data. And that system costed roughly $300,000 to an end user. We put the optimization hardware and software, and we were able to eliminate 50% of the storage expansion units, and we were able to bring down the total cost to $220,000 from $300K. So what I'm trying to, without going into the technical nuances, what I would want the technical audience to understand is, don't go ahead and measure your data in an uncompressed or in a raw format and say, I have 150 petabytes, therefore let me divide that by 2 terabytes and start ordering 300,000 drives. That would not scale properly. And then for my colleagues here from Vertica, this is the test we ran with your parent company HP. And in that case, the HP cluster was one of the most powerful clusters. It has got dual socket 6-core CPUs, 48 gigabytes of memory. And then we ran a similar TerraSort test, and this configuration, given its powerfulness, was able to do the TerraSort in 14 minutes and 15 seconds. Likewise, what we did was, then we took 50% of the disks from each of the data node, we were able to put in our cards or our solution, Exar solution, and we were able to reduce that 33 minutes and 19 minutes in terms of sorting the given amount of data. So what the OEM found was, in the baseline, when they had 12 disks in each data node, if it cost 100% for them from terms of storage capacity, in terms of the performance and the cost, if you use Altior solution and keep the storage same, or Exar solution and keep the storage same, we were able to almost increase the performance and storage capacity by 250%. And if you wanted to keep the minimized cost, then you were able to go ahead and still get the same amount of storage, but at about 50% of the cost without compromising performance. This is the last chart, I would say. So the 4 parameters before you get your CIO or CFO or CEO involved, the 4 parameters you need to optimize are, you need to take the ratio of CPU cores that are there in a given data node and the amount of storage you're putting in it. Optimization of that ratio will save you tens of thousands for an 8-node cluster or hundreds of thousands for a 100-node cluster. Second, storage density. Don't just go and look at your raw storage capacity. Think about data compression. Think about reduction of input data, output data, and shuffle traffic. And then don't get taken away only by CapEx. Just because some OEM will offer you $20,000 upfront less, don't go and buy that system. Understand that OpEx determines, operational expenditure determines the TCO on a 3-year period. So that's where you need to focus between CapEx and OpEx. In summary, if you want to go ahead and get highest rack density, the lowest cost per gigabyte of data, and the fastest analytics, make sure you don't only rely on the most powerful CPUs or maximum amount of storage. Optimize the 4 key resources that you would be needing. And if you have any questions from an architecture perspective or implementation, I'll be glad to respond to that.
Do we have any questions for Amana? Just a quick one.
Sure.
How do you do it, Amana? Obviously, it's with proprietary technology. You won't get into huge into detail, but basically how is it done?
Sure. So if we go back a few slides, at the core of Exar solutions is what we call as data compression technology. What does that mean? In any Hadoop cluster, you have got input data and output data and intermittent data. Traditionally, what customers have done is they don't compress the data that they store. They just go ahead and give a raw data dump, and that raw data dump can be clickstream analytics, all the formats we have seen today. Whereas what Exar solutions do is, without using the CPU, we compress the data and store compressed data. And next time, whenever you see a read as come, we decompress the data in a non-obtrusive manner. So one slide that I'm looking for that I can walk you through. We are using FPGAs to do the hardware acceleration. Absolutely correct. So this is what we do. So everything in the blue that you see, CDFS software and the offload card, that's what we do. So we sit below the Hadoop file system. Whenever the Hadoop file system is trying to write the data to the storage volume, we pull the data aside, bring it to our hardware offload card, compress it here, and then store compressed data on the storage capacity. And the compression ratios are as high, anywhere from 3:1 to 7:1. Why? These are clickstream data, web analytics data. They're highly compressible. You can go up to 7:1 compression ratio, which means that if somebody says you've got 150 petabytes of data, in reality you can store that in 20 to 30 petabytes of data. So that piece of software that does all of it in the hardware offload is what consists of an optimized solution. And if you ask me from an ROI perspective, we are able to eliminate up to $6,000 worth of hard disk from each data node, and this card plus software costs about $1,500. So that's where the ROI came. And just so that you have heard the name Altior and Exar. So last Friday, we were acquired by, when we had the 2 design wins from OEMs, Altior was acquired by Exar last Friday. That's why you would see the Exar name. And we are today part of Exar family.